Let's now consider the problem of computing a prediction interval. Um, Before we even start the calculations, let's just remind ourselves what a prediction interval is in the first place. A confidence interval is a way of trying to guess at what the population mean is. We have a sample of, in this case, 14 chipmunks, and if it's a confidence interval problem, the question is what is the average weight of all the chipmunks in the forest? This is a prediction interval for what will the weight of the next chipmunk be. Now clearly there's going to be more variation in guessing the weight of the next chipmunk than guessing the weight of all hundreds of chipmunks that are in the forest. We have new formulas for computing a prediction interval. They look somewhat similar to the formulation of the confidence interval, except that the thing that's being multiplied by the standard deviation is a little bit different. Okay, so in this question, it's find a 99% prediction interval that gives a lower bound for the weight of the next chipmunk. Okay, so for this problem, the general picture is we have a t distribution with 13 degrees of freedom. And in this case, I want a prediction interval that gives a lower bound. So a number here, so it's at least that much. So I want the area to the right here to be equal to 0.99. Okay, so the mark that appears here, we'll get that with Excel. So the t value we get is equal to t in 0.01 with 13 degrees of freedom. So the number here is that 1% of the area lies to the left, 99% of the area lies to the right. And so, not surprisingly, it's a negative number, negative 2.6503. Okay, and on the positive side, the corresponding mark on the positive side would be positive 2.6503. And the positive number would be the t 0.01, comma 13. Okay, so in the formula for the lower bound that we're going to use, the t, this part here by itself, is a positive number, so that minus that becomes the negative number. Okay, so now we're in the form to find what the perturbation is. The average, x bar, the sample mean, is equal to the average of these 14 numbers, so 8.764. And the error that we have is going to be equal to, well, it's going to be negative C2, if I take the positive number, times the standard deviation of the 14 numbers, times square root of 1 plus 1 over 14. And so the error that I get is about 2.08. Now, if you recall with the confidence interval problem, that is significantly larger than the margin of error that we found for the confidence interval. So the lower bound is going to be equal to C5 minus this error, 6.6765. And so our prediction is that the next chipmunk, the 15th chipmunk that appears, will have a weight that is larger than what we just said, 6.6765. And again, this is a prediction about the next chipmunk and not a statement about the population mean of the chipmunks.